Everybody, welcome to the Electro-Pneumatic webinar, our free Electro-Pneumatic webinar. Our presenter today is David Pieterse. He's one of our PLC trainers and very experienced in electro-pneumatics, PLCs, and instrumentation. My name is Hannes Otto. I'm Manager for Didactic Training and Consulting for South Africa. And yeah, welcome to everybody who hasn't attended any one of our courses, basic pneumatics that we ran on Monday and the basic hydraulics that ran yesterday. We really hope that you get value out of this course. I only have 1.5 hours, but we've got about 30 minutes after the course, after the 1.5 hours, if you do have it. Obviously, like I said, that there's not enough time to discuss everything, so you're more than welcome to attend the paid webinar that we will be presenting in a few weeks' time. We will be at the end of the course, we will show you a short PowerPoint presentation on the courses that we will run and how to register. Yes, please feel free to post any questions that you've got during the course in the chat column or in the questions column. Please raise your hand in the chat column if you have any questions, and we will attempt to answer all your questions as good as possible. So hopefully you enjoy the course. If you consider to attend any of these courses from next week on, we would really ask you to attend the fluid sim course that will be running on Friday. You will also see some of the fluid sim exercises that Davi will be doing now. Fluid sim is a design and simulation program software that we've got. If you do attend one of the other courses, you will receive a free fluid sim package that will be valid until the end of June, and you will do your own exercises and your own practicals during the webinars that will be running on from next week onwards. So it's a really as hands-on as it can. On a webinar, you will, like I said, you will do your own exercises, own designs, and submit your own assessments. And according to that, you will then, receive your certificate of attendance or successfully completion. So if you do have any other questions, please don't be shy to ask. Please take part in the webinar. Participation is also very nice for the trainers, and I really hope you enjoy the course. Thank you very much. Thank you, Davi.
Right, good afternoon, everybody. Like Donna said, my name is David Pieterse, and I'm going to be your trainer today. You guys are welcome to contact us. My cell phone number is also there for questions, and also my email if you guys have any questions, maybe after this session, and you still need to ask questions, you're welcome to do that. Right. It's important for you guys for today is, guys, if you have a question, look at the questions and you can ask questions, and Charles will be my co-host for this training, and he will actually look at the questions and he will actually prompt me to answer the question today. But feel free to actually ask questions anytime you want to. Right, guys, on my screen, I've got now the of content what we're going to cover today. It's important to understand that the objective of this free technical webinar is to give the attendees an overview of electro-pneumatics. That means we're not going to go into much detail, but we will definitely give you enough information, and you will definitely learn and you will get value out of this webinar. As we go on, please ask questions like I've mentioned to you before, and then also please enjoy this and yeah, look at this, and it actually will help you also to make a decision if you want to attend the full webinar. That means the full 4-day course that we will run in the near future, and there within that course we can actually go into much more detail, and we will discuss a lot of things within the actual paid webinar. All right, thank you guys for enjoying this. Please for joining us this afternoon. Right, the 4 topics that we will cover today is the electro-pneumatic system components. Very important to understand the components within an automated system when it comes to electro-pneumatics. Electro-pneumatic control valve, right? And also the electro-pneumatic controlled circuit design. How do you design the circuit and where do you start and from which point do you start? And then I'm going to do a practical application in the form of an exercise that actually can explain to you what we have discussed with into the theory and also the practical for this webinar. Right, electro-pneumatic system components, very important to understand. Components in an electro-pneumatic control system can be identified as belong to 5 basic groups. That means you can take your automated system and all the components that fit into this automated system actually can be belong to 5 basic groups, and you can put them in 5 basic groups and also in that order according to what we will discuss later on during this webinar, the ISO standard for electro-pneumatics. Right, I make a very important statement here. I said actuation devices, final control elements, the process elements, and then input elements, and then also my energy. Now, the energy is the most important thing because without energy, we can do nothing. Now, to start off the bottom of this slide, in this slide, compressor, you got your receiver, pressure regulator, the air service equipment to make sure that you have clean and dry air. And then important also for this webinar, because we actually have a combination between pneumatics and the electrical circuit, the AC or DC power supplies. That means your energy is compressed air that we will use, and then also the AC or DC voltage. All right, in our case, it will be 24 volts for this seminar and for this situation when it comes to electro-pneumatics. All right, to start off from the top, that means your actuation device, that's the device that will do the work for you. That's actually the component that will do the work for you. Pneumatic cylinders, that will be including single acting cylinders and also double acting cylinders. You can also make use of rotary actuators. And then on the electrical side, can lamps, buzzers, and I can actually add onto that also motors if it really comes to that. Then before the actuating device, your final control element, that will be your solenoid actuated directional control valves, and also in our case it will be relays. That will be the final control elements. Then the process elements, right? And when it comes to the process elements, solenoid actuated directional control valves also fit into that group. Then also logic elements, right? And then also pneumatic electric converters. And then also your relays again. Your relays also fit into the same group. Then your input elements. Now that is all your limit switches, push buttons, proximity sensors. That will include capacitor sensors, inductive sensors, your optical sensors, and also your magnetic reed switches. That is all the input elements. That means that this is the 5 basic groups of components that fit into an automated system when it comes to electro-pneumatics. All right. Very important to understand also, guys, components in the system, right? I'm going to show you to you now. Components in the system are represented by the symbols which indicate their functionality or their function. Now, I make a statement here for one reason, so that you guys can understand that each component have a symbol, and the symbol represents the function. All right, and that means the indication from the function side, it is the function of that component. All right. That means also important to understand the symbols are then combined to represent a solution for a particular control task. And this representation forms the circuit diagram. That means I put all the symbols together. That will actually represent each component within an automated system or a machine, for example. And that makes up my circuit. All right, and it's always important when you guys are attending, maybe in the future, our paid webinars. There we teach you guys how to actually use the symbols and also understand how they develop the symbol, what is the construction of the symbol. And then if you put them in a combination or put them in position where they're supposed to be, right, it's always important to understand that when you arrive at a machine and there's a machine right in front of you, all the components are not within the same order or the same levels as what you are going to experience during this training now. Each component are in the position where they're supposed to be fit onto the machine for that functionality. But now it's important for us to teach you guys how to put that components into a drawing or a circuit format, so that you can utilize that drawing for troubleshooting or maybe for maintenance or for any maintenance purposes for the future. That means within our electro-pneumatic courses, we teach the guys how to design the circuit and how to develop the circuit according to a specific machine that you actually already got. Okay, this is now the system components. Very important to know when it comes to electro-pneumatics. We talk about two different circuits. On my left, on your left actually, on the presentation, we will find your pneumatic circuits. Then on my right hand side, it will find the electrical or the electro-pneumatic circuit. That means your electrical circuit. Important to know that this is exactly the same way that you will also experience it when you utilize our Fluid Sim software, right? That you can utilize to design a circuit that is a purely pneumatic circuit or electro-pneumatic circuit. All right. The standard that we use is an International Standard Organization 1219. Very important to understand that each symbol have its standard within to the ISO levels. Right. Now, to come back to the pneumatic circuit on your left-hand side, your energy flow is always from the bottom to the top. That means when you follow or when you actually analyze your pneumatic circuit to understand what is the working principle or the working process of this machine, you start from your energy level and you work your way up until you get to arrive at your actuator. Now, we normally talk from the working process will be from the left to the right, from the bottom to the top, and from left to the right. Now, when it comes to your electrical circuit, the energy is from the top. That means your energy supply is from the top. That will be, for example, in our case now, 24 volt. All right, the energy is from the top to the bottom. That means also your energy flow, right, from the top to the bottom, and then your analyzing of the circuit will be from your left to your right. That means you start off with, for example, in this case, we will start off with line number 1. And the moment when we actually energize or press this push button, right, that circuit will be the start circuit, and it will follow as we go on onto the circuit, what will actuate it next or energize next. All right, that means electrical circuit works from the top to the bottom, and then you analyze it from left to right. Very important principle when you actually analyze a circuit, to understand how electrical and pneumatic circuits actually must be analyzed when you actually want to understand what is the working principle or the working philosophy of this machine. Right, now I'll make a statement here again. I say components in a system are represented by the symbols which indicate their function. That means if you don't understand the symbols, or you cannot understand the symbols or identify the symbols, then it becomes a little bit difficult to understand also the functionality. But we can try our best now today to introduce you to the symbols. Some of the symbols we will actually go into much more detail, and Charles have done it into our basic pneumatics on Monday, and he actually also have done it yesterday with the basic hydraulics. Now today I'm going to try my best to go over that, actually give a little bit of an overview what I already have spoke about yesterday and the day before. All right, your cylinders, right? When we talk about the cylinders, and I've mentioned to you already that we will make use of actuating devices that will be double acting cylinders, and they, on my left hand side, we got a symbol of a double acting cylinder, and then on the bottom that is our single acting cylinder with 2 examples of photos that I've put there. I want to mention this to you so that you also know this. When we do our paid seminars, we make use of real industrial equipment. The only difference between the equipment that we use within a training environment is actually the base of the installation onto our profile plates. It makes more sense for us to make use of actually real actuators that are being used within the industry, because that is what the guys will experience working with and what they actually will work with when they do some training, work or installing it on their real machines or applications on the plant. Okay, then I'm going to go over to single acting to give you a little bit overview again what have been discussed in the basic pneumatics. But this is our single acting cylinder. Cylinder require one pneumatic control. That means if you can look at the picture, you can see that there on my photo at the back, there is your inlet port. Cylinders require one pneumatic connection and an exhaust port in front. Because this is a single acting cylinder, there is different types of single acting cylinders that we make use of. There is, in this case, this is a normally retracted one. There's also two other ones normally extended, and then there's also actually that is extended but can be retracted when there is a signal given to it. Right, the exhaust port must be clear of obstructions to ensure that the piston is not restricted by the air passage. That is in the front. Air filter is normally fitted to the exhaust port. Why? Because of actually any dust or any environmental things that in the environment that can be actually sucked into the cylinder, and that will actually damage our internal parts of our single acting cylinder. Right. Discussion, the importance of selection, the size. Guys, that's also important for selection when you select, or your selection when it comes to the criteria for selecting a cylinder for a certain application. It's always important. I think you guys know and understand that in a technical environment, there is electricity. That means electrical circuits. There's also your hydraulic circuits, your pneumatic circuits, and then from all that, there can also be a combination. But your criteria must be the force. Force is one of the criteria. Stroke length is one of the criteria. The type of motion. When I mean by motion, is it linear motions, a straight line movement, or is there also rotation involved? The speed is involved, but all that will be discussed in more detail, absolutely more detail, when it comes to the basic pneumatics course, the full paid webinar, and also the same when it comes to electric-pneumatic course. Okay, here is an example to have a little bit of more insight into how it looks like internally when it comes to the single acting cylinder. There's a spring internally. There's a spring, so you guys also know that. Like I've mentioned to you, the moment when the air supply is supplied to the port at the back, your air supply at the back, it will extend, and the moment when that air supply is not available there anymore or not present there, the spring will force the cylinder to retract to the rear end. That means the question that you can ask yourself, what is the motion? This is a straight line motion. That means it will do work in one line, a straight line linear motion, but it can only do work into one direction, right? And then when we go over to the double acting cylinder, right? The double acting cylinder, right? They say the double acting cylinder are used particularly when the piston is required to perform a work function in both directions of motion. That means we normally talk about push and pull. If you want to push something or you want to pull, right? That means the construction is in general similar to a single acting cylinder. That means it looks the same. The only difference is actually that there is two ports, one port at the back, one port at the front, right? For a signal, that means it's air signal to send it forward, or actually an air signal from the front to the back. That means to send it to the back again, right? Therefore, a large number of variations. That means there's also large variations when it comes to different sizes, different looks, and different material that they use to manufacture your double acting cylinders. And then, yeah, also important to understand the materials. And then also you can ask yourself, what is the criteria when you select the cylinders? For cylinders, is again, like we mentioned into the basic pneumatics course or the webinar, is that we talk about force, the force, the speed, the stroke length, what is the position, what's the angle, and your sensitivity, is there safety involved, and also controllability, all right, and a lot of other things that actually is important when it comes to the selection criteria for selecting what type of cylinder must be used for which application. Okay, I do this, I'll show you this slide. It will be there now. All right, there's it. This is important to understand, and we go into more detail when we have open, or what we said, paid seminar. Then we go into a lot of more information. Then we actually discuss each part of the construction of the single acting cylinder or the double acting cylinder. Then we discuss all the different parts, and it's important to understand the different parts, because there is actually, for example, if I can actually on my slide here, and you can see my mouse, I could do that for you, like hold it for me quickly. Right here, you can see that this is the piston rod, but actually at your barrel, you got your front bearing part that actually have that seal right there in front, have a unique reason why it's there. We can also discuss the material, because that is what we call a wiper seal, and that wiper seal material is there for a specific application. Let me talk about temperature. For example, it cannot work in all temperatures. When this cylinder is used in an application where there is high temperatures, then that wiper seal must be of a material that can actually maintain the temperature, or actually keep on going when it comes to the temperature. Then it's also important to understand the bearing, and then there's a lot of parts. You can see yourself, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 parts that will be discussed within a lot more detail when it comes to our paid webinars. I want to mention it to you so you guys know that there's a lot of information still to be learned from pneumatics. All right. Then I'm going to go over to my next slide. Okay, hold on for me quickly. Shop development. Okay. Right. Then it's also important when it comes to the double acting cylinders, or maybe a single acting cylinder, for electrical design, or what we call electro-pneumatic design. For automation, when it comes to automating a system, it's important to know the position of my piston, right? Internal position of the piston for extending and retracting. Where is my cylinder and what position it is? Now, the photo right on my slide show you that there is what we refer to a magnetic reed switch. And that means that there must be something internally inside your piston that can actually sense what position and which position. Right now, on my symbol, on the ISO symbol, we got a ruler, right here, ruler with B0 and B1. That is my actual position for my real limit switch and also for my front limit switch. Then this actually she-shape, this black she-shape actually symbol represents the magnetic ring that actually are installed onto it when Festo installing it or assembled a cylinder. I'm going to go over to the next slide to show you this. On the next slide, you can actually see a cutaway, all right, a cutaway picture or photo of a DNC cylinder from Festo. And you can see that there is your magnetic ring. That means into any position, in your front position or your back position, right, you can sense that magnetic field will actually then are created by that magnet, and that magnet will actually then trigger a signal to my actually re-switch right here on the re-switch itself for sensing. That means it's important. Now, this is contactless. This is important to understand. it's actually supposed to be maintenance free. When you make use of a re-switch, it's actually maintenance free. That means there's no moving parts. The only moving part is internally, not on the outside. That means onto your barrel of the cylinder, there is a slot, and then that re-switch are actually manufactured in such a way that you can see that there's a small locking device on top, right, that you can actually put into place. Right, I want to mention that, so for design, it's important to know the position and what type of sensing device are being used. Later during today, we will actually discuss all the different types of sensing devices, proximities, like I've mentioned to you also already. Right, then also important now, guys, the valves. And now, like I've mentioned to you in the beginning, the final control element, that's the element that controls your actuator, that actually gives signals, right, to your actuator to send it forward or to backwards, or to move it in a linear motion or into a rotary motion. It depends on the actuator or the application that you actually are installing, on the which application this actuators are installed. All right, the electro-pneumatic control valve, important to understand it. Right, first thing, the main parts. Now, this is a typical example of actually all the parts that actually are on your valve, your control valve. I first want to discuss quickly. There is, onto my right-hand side of the corner, we got 1, 2, 3, 4 parts, right? The symbol right here on top, the symbol represents the actual valve, the spool, that represents the spool. Then you have the ports. That means there's 2 squares, and if you look at it, we got 2 squares. We got on your left-hand side, we got a square. We also got on your right-hand side a square. Right, the number of squares, later on I'll explain it to you in more detail. That on the left-hand side, on the right-hand side, there's 2 squares fit together. That is actually representing the spool movement internally. That means we talk about the spool, right, the valve body, the seals inside, the spool itself, and then very important for electro-pneumatics and for pneumatics, this controls. Now we got, look at this. If I actually out of the face, we can see now there is port number 1. Then we have port number 2, we have port number 3, we have port number 4, 5. That's 5 ports, all right? And your actual connections are always on my right-hand side, and we will go into detail with that into our basic pneumatics again. This on your right-hand side is what we refer to the initial position. That means when you look at the symbol of a valve, the actual connection is always on my initial position. What we refer to, it is actually air off or mechanical off. That means in the position of this actually standstill, if I can call it like that. That will be on my right hand side, and we will go into a little bit more detail. All right, now the first thing is my valve body with my ports. Like I've mentioned to you already, there's port number 1, and if you work with this before and you are familiar with pneumatics, you will know that port number 1 is my supply port. Then my actually port number 2, right, in this sequence from 1 to 2 on the air must flow for my cylinder to retract, for example. Also onto my actually port number 4, we got then that's outlet port. And number 2 and number 4 is my outlet ports, all right? Normally they are labeled, in the past they are labeled by alphabetic letters A and B. Actually we use actually numbers now because of actually there is countries that don't use the same number system, or actually not number system, the alphabetical system as we got. That's why we use digits, right? 2 and 4. Then we got port number 3 and 5. Port number 3 and 5, and I will give you an explanation with an animation later on again to remind you what you have learned on to the previous courses. Right, port number 3 and port number 5 is my actual exhaust ports. Right, then we got our seals internally because of the movement of my spool inside. Then I've got my spool. Now that's the sliding part internally inside the housing of my valve body. Right. And the spool, actually, the symbol represents the spool movement. Right. When on your right hand side or on your left hand side, that means there is two positions or two switch positions with 5 ports. All right. Now I'm going to show you a cutaway. I want to show you a cutaway of the main parts of a valve. That is 14 and 12. That's my two controls. All right, and now I'm going to show you the cutaway one. Right, here is a cutaway of the main parts of a valve. That means this is what we refer to a 5 to 2-way, because there's two switch positions. You can actually see on the photo here, we got our spool, we got our 2 ports here at the bottom. All right, that is a port number 4 and a port number 2 and number 4. On top, we got the middle one is my supply port, and then we got our 2 exhaust ports. Okay. Important to understand this now is on my left-hand side and my right-hand side. That is where we actually have your solenoid valves, the solenoids, and that is your controls. And normally we label it. We label the solenoid valve or the solenoid itself according to the number of the air flow through, and I'm going to explain that to you later on again. This is to help people to understand what I'm talking about, and also understand if you never have attended any formal pneumatic course or you haven't attended any webinars, it's important to understand that part also. Okay, then important to understanding, guys, we're going to go over to the actuation. Now, when it comes to pneumatics, all right, on your right hand side, we got a pneumatic signal or symbol for pneumatic actuation. We also have a manual actuation, then mechanical actuation. But we're going to concentrate today for this webinar, we will actually concentrate onto our solenoids. That will be the electrical actuation. All right, that will be the electrical actuation. All right, now I'm going to go over to, right, now valve construction. Very important to understand this, guys. The valve construction and the symbol. All right. If you look on your right hand side, you will see that there is 2 symbols. Your symbols on your right hand side is what we refer to. The top one is a single solenoid valve. Then we need to explain. All right. First, they say on the left hand side, we talk about the steps. Number of ports. That means if I look at it, it's port number 1, port number 2, port number 3. That means, right, we got here, right here where my spotlight is. This is my port number 1. I've got my outlet port, port number 2. Then I've got my exhaust port number 3. That means if I need to identify this valve, I will start off with the number of ports. Right, that will be 3 ports. Then the number of squares. If you look at the squares, there's 2 squares again. Right, let's explain it to you in such a way. Okay, right here that is my first square. Then this is my second square. That means this actually includes 2 squares. Immediately that will indicate that I have 2 switch positions. That means this is the part. I've done that part. I also have done that part now. Then the condition. Guys, now the condition is what we refer to actually then. Is it actually normally open or normally close? All right. Normally open or normally close. Now you can see now that as my air comes in here, all right, it actually will be blocked, or we actually say locked there. That means it's not there. It cannot go through. That is what we refer then to as a normally close. Okay, that the air cannot go through. When we refer to this, when it comes to electrical symbols, it's the opposite. That means normally closed with an electrical circuit, that means if a contact is closed, the electricity will go through, there will be a flow of current through it. But when it comes to pneumatics, and normally closed is the opposite as electrical symbols. That means a normally closed means the air cannot go through, to make sure that everybody understands that part. We also get normally opens, all right? Then a method of actuation. If I refer to the method of actuation, I'm talking about this part right here. This is the method of actuation. That means I can actually then go through three things there to make sure you can understand all three of the symbols that we make use of there. The symbol right here, where my cursor is, that symbol represents the solenoid valve. Then this symbol right here is what we refer to the manual override. All right, that means if there is no electricity, there's actually a power outage, or there's a power failure, and you want still to move it or to actuate it, you can actually manually actuate it with that key. It's normally there's a key or a slot or a push button. Then we got this symbol right here is what we refer to an internal pilot line. It's an air signal, and I'm going to show that to you. I will identify that to you a little bit later on again. Right, this is now the method of actuation. Then the method of rest position, or the method of rest. That means is right here is my spring, and we call that spring return. It means if your solenoid valve or your solenoid are not energized, you did not press the manual override, then the spring will reset my spool internally to the rest position. That is on my right hand side. Okay, then that is what the method of rest means. Then the port size, guys. Now the port size depends on the size of the valve, right? And it depends on the size of the hole that you can actually thread with turning thread there, that you can turn a fitting into. That's the port sizes, and that will be determined by the size of the valve. Very important for design, and also when it comes to speed control, you need to understand what the port sizes is. Remember now, the bigger the orifice size of your port, the more air can flow through it. I think everybody understand that. That means the larger your airflow in liters per minute can be there. I'm going to show that to you. Right, then on the bottom, we got now our what we refer to a 5 to 2-way valve. That is a 5 to 2-way. That means there's 5 ports, also 2 switch positions. That because there's 2 squares. The condition in this case, it is on either side. That means on both sides, on the right hand side, on your left hand side. It actually actuated and non-actuated. It actually, and this is a very unique, what we refer to an MCV. This valve is a MCV. This is what we refer to as MCV valve. Now, what does MCV stand for? It's called a memory control valve. All right. Now, we utilize this also within Electro-Pneumatics. Very important. There's a solenoid on both sides. There's solenoids on both sides. There's also a 2 on both sides. There is your manual override. On both sides, we got your internal pilot lines. And then that means when you want to identify this valve or describe this valve to somebody, it's important to understand that you cannot tell them that it's normally open now, because it's open in both the 2 positions, on your right hand side or your left hand side. It will either go from 1 to 2, the air will flow from 1 to 2, or it will flow from on the other side from 1 to 4. Right. I want to bring in here something very interesting. I will quickly show this to you, and I want to demonstrate it to you. Right. Give me a moment. I quickly want to clear my. Okay. And I'm going to go to. All right. I want to show you this. Right. First, I'm going to show you the single solenoid valve in the form of actually. Right. This is my single solenoid valve. All right. On my left-hand side is my single solenoid valve. And then I also got my spring. Right, now look at this. The air currently come into our supplied on port number 1. And now it flows through because of the symbol from 1 to 2. The air will go and flow through from 1 to 2. Currently, my internal line is there's an internal line, internal pilot line that I tap off from the main supply. All right. The moment when I energize 14, my spool will move over. And as long as there is power on the solenoid valve and it is energized, my spool will be in that position. Now the airflow from 1 to 4. Right, and the moment when you decide to de-energize your solenoid valve, right, also important now for the future, if you come and attending any of our courses, remember that the labeling for your solenoid valve is currently 14. Now we start off with 1, 2, 3, 4, 5. And why now suddenly some of 14 and 12? It is because of the airflow through it. That means the airflow from 1 to 4. That's why when you energize this 1 to 4, on the right hand side, if I release the power, if I actually don't de-energize it, the spring will reset my single solenoid valve, and now the airflow from 1 to 2. That means my spring actuation, or what we refer to reset, will then actually reset my valve to go to the unenergized position. All right, now the air will flow from 1 to 2. All right. Right, now that means when we actually go to, and I'm going to quickly show that to you also again. I quickly want to show this to you. This will make sense for everybody that actually have attended our previous courses also. All right, now to relate to what the symbol, or actually the construction of my symbol, we got our double acting cylinder, right? And the moment when I actually energize from the left, that means on this side, right, on my left hand side of my valve, the spool move over, and the air flow from 1 to 4. The air flow from 1 to 4, and my cylinder will extend. Now look at the symbol. Look at my symbol now, guys. On the symbol itself, you can see now on my symbol right here, we are now on your left-hand side. We are on the left-hand side, right? And the moment when I energize my cylinder again, okay, we go back. All right. Now that it is, that means now you know now how your cylinder works. All right. And with the valve, we're going to go now over to the next slide. Right, guys, here is the electro-pneumatic valve design. Right, this is solenoid principle. How does the solenoid works? Very important. When electrical signal is applied, to the solenoid, a magnetic field, right, guys, is set up and cause the valve to switch. That means the moment then we actually are energizing here, electrical signal, is applied to the solenoid, a magnetic field is set up and they cause this valve to switch over. Right. There you got a basic understanding of the working principle of electro-pneumatic valve. Right. Like I've mentioned to you, here's an examples of a 3 to 2-way valve, solenoid valve again. Now, on your left-hand side is the pneumatic circuit symbol, and on my right-hand side is my solenoid for the electrical symbol, the symbol for the electrical symbol. Right, the same on your 5 to 2-way double solenoid valve, and I've mentioned to you now this is what we call an MCV. All right. Now you got the basic understanding of the valve and also the actuator. Right, now here is a circuit where you connect a single acting cylinder and also a double acting cylinder with a 3 to 2-way single solenoid directional control valve, and then on my right hand side we refer to that is a a double acting cylinder with a 5 to 2-way double solenoid directional control valve. That is what we refer to MCV. That means my MCV will be on my right hand side, and my single solenoid valve for 3 to 2-way on my left hand side. All right. Now, guys, when it comes to the actual electro-pneumatic control circuit design, how do I design? How do I start? Where do I start? And what do I need to understand? What is the principle what I need to apply when I design a circuit, electrical circuit? And this is important. Right, first thing first, within the environment where you use a power supply, for example, now here we actually show you an electrical connection is my 0 volt. That means this is a symbol that they will use also within our fluid sim. We use this symbol for our 0 volt indication. That means what I said here, components in the system are represented by the symbols which indicate their function. That means this is my 0 volt. Then I've got my 24 volt symbol for the 24 volt. That means my 24 volt connection. All right, remember now this is my DC power. That means DC supply. All right, 24 volt DC supply. Right, and this will indicate, now most of the times we actually refer to this as a lamp, but within the fluid sim actually that we can utilize the simulation package that I will introduce to you now. They call this a light indicator light. There is a module that we use within training, what actually we can actually help the guys to understand a lamp, or also actually when you power it up. If the current flows, the indicator light is displayed in the user-defined color. Normally, it's actually 16 standard colors, and in our case, it will yellow. And I'm going to show that to you when we do the fluid sim. That means when the lamp comes on or the light comes on, it will be a yellow color. I'm going to show that to you or demonstrate to you. Right, very important to notice. That means we got our 24 volt, we got our 0 volt. That means we utilize 230 volt AC. Convert it into a DC voltage, and then we have our lamp indicators, right? We know that we can supply power to our light, or what we call lamp indicator. All right, guys, now very important when it comes to electro-pneumatics, to start off designing a circuit, a control circuit. Very important to know this. We utilize, in this case, we use a lamp or a light, power to my 24 volt. And my 0 volt, right? And that is now my push button. That means for the IEC standard 61346, we need your push buttons, symbols, and you need to understand the symbols of the push buttons. All right, that means there's your power supply. We got our power supply, we got our push button, and we also got our normally open and normally closed push button. To understand the symbols, all right, within electro-pneumatics. Then also there is a symbol that represents detent, right, normally open, right, detent switch, or normally open, all right, contact. Now, guys, to understand a detent, we normally refer to that as a latching push button. When you actually push it, it latches in position. And when I push it again, it will unlatches. That means this is what we refer to detent. Okay. Now, when it comes to electrical connection within the electro-pneumatics, there's a few principles, and everybody knows Ohm's law. There's Ohm's law, right? When we connect two components, for example, now when you connect two components, right? Two or more components are connected in one line. That means when they are within series. What is the philosophy? What is actually the principle here? When it comes to the current, when current flows over both the components, you will measure the same current. But when it comes to two components that are actually in line, that means on series, connected in series, like two lamps, then the voltage will divide. I'm going to demonstrate that to you now. Then on my right hand side, two or more components are connected in their own lines. That means both are running from their own line, from their own supply. All right, going to this thing, right, actually supplied from the same power supply, then the current will be divided between the two. I think that's, everybody understand Ohm's law. If you don't understand it, please ask. Then the same voltage, that means you will measure over that component the same voltage. That means there is a difference when it comes to your current and your voltage within a series circuit and parallel circuit. Now, I'm going to show you the next slide. The next slide, I want to show that view within our fluid sim, all right, fluid sim, the fluid sim simulation package. I'm going to draw it for you. I already have done it already. I'm not going to actually do it from the beginning, but I will show that to you. I want to bring in my fluid sim package within it to explain to you what's going on here. First thing first, let me quickly explain line number 4. We have a push button with 2 lamps in series. Now look at that, and when I close my normally open contact, when I close it, and then I measure, actually in parallel, I measure the voltage over both the 2 components. That means our 2 lamps. I'll measure 12 volt and 12 volt, right? That means the voltage are divided. You will have measure, if you measure the current, all right? If I go back here, look at it, divided, the voltage will be divided, but the same current. That means if we go back to this one, we actually then measure, all right, we will measure the same current. When it comes to a parallel circuit, if you measure over the components, you will measure the same voltage, right? The same voltage, but now my current will be divided. Right, now let me quickly explain it to you guys. I'm going to bring on my fluid simulation package. Right, I hope everybody can see it now. Charles, I hope you can see it. All right, I'm going to bring in my circuit.
It's good.
Thank you, Charles. Okay, I also want to mention this to you now, guys. On Friday, we will definitely go through a proper explanation and demonstration and exercise when it comes to the development of circuits, pneumatic circuits and electrical circuits. That means electro-pneumatic circuits, the same with the hydraulic circuits within the fluid sim. That means the webinar that we will present on Friday will teach you a lot of things about your fluid sim, the software package that we actually talk about. Right, now look at this. I said now the series, 2 or more components are connected in line. The same current, right, let me quickly simulate this. I'm going to go to the simulation there. Right, the moment when I press my start button, this is a normally open push button. I'm going to press that. Right, there you can see now there is my voltage, all right, my multimeter that I've actually connected to the lines. It actually showed me that there is a voltage of 12 volts over both of the, right, of the top one and the bottom one. That means divided, the voltage are divided, the 24 volts are divided. The current is the same. Right, then we can go to the right hand side. That means when we go to the right hand side, we can click onto this. It will show you now that the voltage will be the same, all right, on both. It will be the same, but your actually current now are divided. All right, that is now the difference between a series circuit and a parallel circuit. Please take this in consideration, this principle, or what we refer to as your Ohm's law. Then also important, when you connect, for example, the philosophy or what we refer to the logic, when we come to the logic logic operation within electro-pneumatic circuits, guys, here is a push button, right, and another push button. That means the moment when I actually, for both of them, actually that is what we refer to an and function, all right. I need both of them, all right. And then also on my right hand side, we actually have then normally close, all right. We don't normally open, that we press. This is either this one or the other one. That is the OR function within electro-pneumatics. Okay, now back to my presentation. Right, here we got now, very important to understand this type of control. When you start designing within electro-pneumatics, we talk about direct control or indirect control. Now, I want to demonstrate it to you. I've got now my pneumatic circuit here on the right-hand side. I've got my electrical circuit on my right-hand side, and left-hand side is my pneumatic circuit. All right, and explain to you each of this control. That means I'm going to go over to direct control. Now, guys, look at this. If you want to control a single acting cylinder with a 3-to-2-way single solenoid valve, right? If you want to control it electrically with a solenoid valve, on my right-hand side is my electrical circuit. That means my push button, the signal that creates or sends the signal, the power signal, it will be connected directly onto the solenoid valve. And that's what we call direct control. That is like a manual operation, direct control. Then we can go over to, right, next one. Like I said to you, pneumatic circuit on my left-hand side, electrical on my right-hand side. Then we got indirect control. Now, guys, if I use a double acting cylinder with a single solenoid 5-to-2-way spring return valve, and I don't want to actually directly control it, I will make use of what we refer to a relay. That means on my electrical circuit, we got a push button. The moment when I press my push button, I will energize my relay number 1. Then internally, it depends on the contacts, single contacts, normally open or normally close, or maybe change over contacts within this relay. I'm utilize one of relay number 1 contacts. The moment when that contact closes, I will energize my solenoid. That means this will give me then the opportunity then to start automate my control circuit or my automated system. Right, I want to quickly go through, before I actually do this physically on the fluid sim, I quickly want to go through, right, there's your pneumatic circuit, electrical circuit. I want to go through the symbols, guys. There is, I'm going to go through this quickly. There is what we call a brake switch, right, that everybody know or refer to a normally close. We got a normally open, that is called make switch. All right, we got a make switch. This is a make switch. All right, a make switch. Generally, make switch is tailored according to the component that actuate it. All right, very important. There's also other devices like delay on or delay off. All right, we will come to that in the future when you do the electro-pneumatics with timers. Then we got what we refer to, the next one will be called a changeover contact, a normally close with a normally open. We also have your limit switches, very important, your limit switches. All right, this is a limit switch. The symbol for a limit switch, a brake limit switch, that means it's a normally close. Then it's important to use a mechanical, what we call switches with rolls. Right, they call it a mechanical switch. That means it's a rotor lever limit switch, a normally close contact. Then we got a symbol. This is my symbol for a read contact. All right, and then we have a limit switch that's a limit switch make. That means a normally open one. Then we got a switch roll for making again. All right, for make. All right, guys, that is now all the symbols that you need to understand and know how they work and how to identify them on a circuit. This is a read contact, make contact. That means the switch is closed by a cam attached to the cylinder rod. The switch opens immediately when the cam has passed the switch. The read contact are created by using a digital make switch, setting a label or selecting a switch type in the component properties dialog box. Now I'm going to show that to you. Right, I will quickly show that to you. Right, now I'm going to skip a few of my slides only for time purposes. Guys, I want to go to my exercise. There's all the contacts. I've discussed all of them. I'm not going to go into much detail. Okay, guys, here's also important to understand this. Here we got your magnetic proximity sensors. When we actually do your electro-pneumatic circuit, we deal a lot with actually your symbols and working principle of all the proximities. Now, this is a magnetic proximity switch with its symbol, and it can be a PNP or a PNP. It all depends on the transistor that you use internally. Right? Is it normally open or normally closed? This is a physical normally open. All right. What we refer to as supplied power. All right. And then we have inductive sensors. We go through inductive sensors also. We utilize that also within our courses. And we're also dealing with capacitor sensors. That means the capacitor sensor. Optical, we also do the optical sensors, all the optical sensors. Then we also deal with pressure switches, and we go through a pressure switch. Then we also do what we refer to a pneumatic to electrical converters. This is, for example, a differential pressure switch, a coupling, pneumatic, electrical, and mechanically. Right, now I want to do a practical application to actually demonstrate to you, right, you know now some of the actually symbols and the standard symbols. Right, I'm going to go now to this exercise. This exercise that I'm going to show you now is basically, right guys, it's basically double acting cylinder that controls by a single solenoid valve, 5 to 2-way. That is to open to fill. There's containers at the bottom, and I want to fill the containers with a liquid, and then that is the shipping off to a company, right? And that is a filling machine. And this is what we refer to as direct control. I want to do this physical exercise now within fluid sim for you. I want to simulate it and show you how to do that and how to do the design. And this is some of this exercises is the exercises that we utilize when you guys start doing the exercises within a real paid webinar. Right, I'm going to close this now. Say no. I want to start off right I assume everybody can see my fluid sim show. Okay.
Yes.
I'm going to go to file, and then I'm saying new file. To open a new file, that is now to design a circuit. Now remember what I said to you, there's two circuits. There's an electrical circuit and there's also a pneumatic circuit. I'm going to start off with the pneumatic circuit first. I'm going to go to the page setup, drawing size. This will be explained to you in a lot more detailed actually demonstration and working or philosophy of the fluid sim when it comes to Friday when we do the fluid sim webinar. Right, I'm going to go to within my fluid sim. There is what we refer to now a standard library. The library consists of the pneumatic electrical controls for IEC, electrical controls for NEMA, then miscellaneous digital electronics, digital technologies, graph set for the guys who have do PLCs, then also easy port. All right, we will do that on Friday. We will demonstrate all this stuff with you on Friday, but for now I want to start off right, and we said we're going to use it in a, remember now your PowerPoint presentation said that we need to use a double acting cylinder. All right, I'm going to utilize a double acting cylinder. In the meantime, I also want to show you and demonstrate you the single acting cylinder. Right, this is now my actuator. I'm going to go to view and fit the window. All right, move this a little bit to the right hand side. There's my two actuators. Left hand side, single acting cylinder. Right hand side, your double acting cylinder. Right, then we need a final control valve. Right, that means I'm going to go to directional control valve, the configurable ones. And on your double acting cylinder, I want to utilize a 5 to 2-way. That's a 5 to 2-way valve. All right. And then on my single, I'm going to use a 3 to 2-way valve, for example. Okay. Then I also want to actually have my energy. My energy is very important. Right. I'm going to go to supply. This actually symbol represents my compressor. And then I'm going to utilize what we refer to an air service unit. And most of the times we make use of a simplified air service unit. Okay. Now how the connection works, guys, it's easy. My compressor needs to be connected to my service unit, and the service unit need to connect to port number 1 onto my single solenoid, my 3-to-2-way valve. I'm going to do another connection onto port number 1. All right, right there onto my actually air service unit. Then I'm going to go now, guys, and important to understand this now, we need to connect our outlet ports from the valve, and like we have discussed now, we got now a 3-to-2-way. 3-to-2-way, that means there's 1, 2, 3 ports, 2 squares, right? And my rest position, or what I refer to my normally position, or my normal rest position, will be on my right hand side. That is the initial position of the spool. All right, same on your father 2-way valve. Right, this is connecting to my double acting cylinder in front, this one to the back. All right, that means the moment when your air supply is switched on, the air will flow through from port number 1 to port number 2, and it will send my cylinder into the rear position. Right, and then if they actually wanted to extend, now I also want you to understand this, on port number 5 and port number 3, we need to connect. For example, now in an environment where there's a lot of noise, we need to put silencers there. Right, I'm going to put a silencer on both the outlet ports. That is my exhaust ports. Right, now I need to actually do the same thing on my single. Double click there, go to exhaust port. Okay. Now, I put a silencer onto it. That means because of the noise, then I connect my outlet port to my, actually at the back of my single acting cylinder. Right, now this is now, you got your actuator, you got your valve, but the actuation of my valve, that means the actual actuation of my valve, I want to do that part. That means I'm going to double click onto my symbol of the father 2-way valve. Then I'm going to go to the properties. You can see that there's properties. I'm going to go to the configure valve to configure it. What do I want to configure it? That left actuation and the right actuation. On my left, there is your manual operation, manual actuation, mechanical actuation, and pneumatically in electrical connection. Because we are dealing with electrical, we want to have an electrical actuation. That means this will be my solenoid. All right, and then on my right hand side, according to the exercise, that must be a spring return. That means we need to use for right actuation, we need to use a spring. All right, not pneumatically, not electrical, mechanical. All right, mechanical, that means we need a spring right inside here, but it means that there is an option to tick this tick box, spring return. The moment when I add that is a spring return, then I'm going to actually also label the solenoid valve. Now here, when you actually label it, all right, when I label this solenoid valve here, I'm going to make that Y1. All right, let us use actually Y1 and say okay. Okay, the moment when I do this, my solenoid valve here is labeled Y1. I'm going to do now this for this one. Double click onto the same thing. Okay, and I'm going to go to the label part, and this will be, for example, my Y2. Right, and I also want, for example, a single solenoid and then also spring return on that side. All right, it means now now I'm going to go over to, now I've got my pneumatic circuit. I want now to do my electrical circuit. Okay, I'm going to actually make my circuit a little bit smaller, move into the left hand side. Okay, now guys, also important now is the moment when you start off with electrical circuit, you need supply. I'm going to go to the supply. All right, electrical controls. Very important, the supply, power supply. Click on my 24 volt. also going to click on my 0 volt. I've got my 0 volt. Right? And that means I'm now going to go to right and add myself a 24 volt. I'm going to highlight this, right click onto it. This will be done on Friday again with you guys. Explain to you in much more detail. Same within this one. Copy that and paste it inside there. The whole main list there, swap that into that. Okay. Right, connect my 2 lines. Okay, now I want to actually, the moment when you press a start button, I'm going to go to my library. I want to press a start button to energize my solenoid. That means I'm going to go to relay. There's my solenoid valve, and this is now direct control. Connect my solenoid valve onto my 0 volt line, and this, right, then I'm going to look for my switches, control, all right, or switches here. There's a manual operation, a push button. Click onto it, drag to move it into position. All right, and then connect it right there to my 24 volt line, and then to my actually relay. All right. Then I'm going to label this. This actually is my solenoid valve. Now I want to operate my double acting cylinder directly when I press the push button. That means I'm going to click onto my solenoid valve and then label that as Y1 and say yes. Okay, now look what happened here, because that is already there. All right. It means if I'm actually doing this, I'm going to show it to you. I'm going to actually then go to this part. I think I'll do undo. I'm going to actually take this, because this is a solenoid valve. I'm going to take that and delete that now. I want to show you something that's actually very important. When I click onto the solenoid right here, it actually wants me to actually put it under there. That means if I actually label this one, if I'm going to go back into this one, label it now as Y1, Y1, yes. No, it's not Y1, it will be Y2, sorry, it must be Y2. Okay. Oh no, man, it's not there. Sorry guys, this is actually, now I'm actually make my labeling the same as what we have previously. All right, let me do the first one. Yeah, I think that's good. It's a good idea to do that. Is to actually double click onto this one. All right, I'm going to take this off for now, because my labeling must be exactly the same thing. Otherwise, you will get yourself to a point where you can actually have trouble with it. Right, first I'm going to do this on my double acting cylinder. Right, that means I'm going to go to this valve, double click onto it, make sure that that is Y1. Identification on the label already exists. Continue anyway, say yes. Okay, and that means I'm going to take it off there. Okay, and then this must be labeled according to what I said there, Y1. So, okay. Okay, now I'm going to go to the simulation, guys. When we go to your simulation, remember now the exercise want to fill the container. The moment when the operator press the button, that means I'm going to actually also click onto my push button. And I'm going to give it actually say push button. Number 1. Okay, that means I'm going to go to the simulation here on top, click onto my simulation. Right, the moment when I press my push button, there my cylinder will extend. It opens the valve so that I can actually let the liquid flow into the container. And if the operator are fault up, actually I'm going to go back and then it will return to that. That is now what we refer to as a direct control. A direct control. I'm going to also do the same thing for my actually single acting cylinder. That means for the single acting cylinder, what we can do is I'm going to add myself another push button. I can also utilize the actually what we refer to your relay. All right, go there to the relay, connect that into this, and then also right straight there on top. And oopsie, there's it. I will click onto this. Ach, my genade. Okay, please push. All right, push button number 2, for example. Okay, and here is something wrong. Yeah, let's quickly check what that problem is. Go to that one there, connect it again. Okay, and now I'm going to go to my solenoid valve onto that one and make that Y2. And then this must also be done for Y2. Okay, and that means when I put my simulation on, that means this is both are them for the single acting cylinder and your double acting cylinder. We actually call that direct control. That means there my solenoid actually energize onto the single acting cylinder, and my cylinder will extend. The moment when I release my button, it will actually then return to the rear end. Okay, and now also important, we can go over to what we refer to your actually indirect control. I'm going to do that for only for the farther two-way, right? But this time I want to change it a little bit. I want to make it according to my PowerPoint. I'm going to show the PowerPoint to you. I've got an exercise. I say here is actually they use a double acting cylinder again with 2 push buttons. That is still single. Sorry, this is double acting. That means MCV, what we call the memory control valve. Farther two-way MCV. Okay, push button number 1 and push button number 2. That is to lower this bucket into a hot boiler to pick up some gold, for example. This is now what we refer to a manual operation or a direct control. I want to change it a little bit. I want to make this actually indirect control. All right, that means I'm going to go back into my fluid sim. Go to the configuration of my valve, double click onto the configuration of the valve, all right, and go to the configuration and make this also now a double, right, and take the spring off, change my configuration into a double solenoid on my left actuation and on my right actuation. There must be a solenoid valve. That means a yes. Okay, that means this will be now a farther two-way double solenoid valve. Okay, I'm gonna only for now I'm gonna delete this so that it not will influence my circuit. We can actually stay that if we want to, but let me do that. I'm gonna stay that. I'm gonna click on this one and make this one Y3, for example. So okay. Right, this is not according to the ISO standard. When it comes to the ISO standard, you will always start off with Y1, Y2, and then this will be Y3. All right, but only because I've actually explained or demonstrated both of you, I'm going to do this as a Y3. Now I'm going to change this. And guys, if we go back into my presentation, I want to quickly show you something before we go. Give me a moment, it will be with you now. Right, if you can see on my slide here, I'm using a normally closed switch, but this switch is connected to a relay. That means in this box here, what we use here is a relay. That means when it comes to actually what we refer to as indirect control, we make use of relays. That means I'm going to go to a relay. Okay, there's a relay now. I'm going to actually then label the relay as R1. Okay. That means the moment when I press my push button, I will energize my relay. And then I'm going to use a contact of that relay. A contact, that means I'm going to go to switches. Make switch, I'm looking for a make switch. Okay, let me put that into position. This contact needs now to be connected to my relay. All right, it will be R1. Say okay. All right, and now I also need to understand now the moment when I press the start button or the push button, relay 1 will energize, R1 will energize, that contact closes, then it will energize Y2. Now my cylinder will extend it. All right, it will be Y, sorry, this must not be Y1, it will be Y1. Let me quickly change that. Hold on for me. This must be Y1 now because of my double acting cylinder. Okay, and it means now Y1 will energize. That means the moment when my cylinder goes forward, I need to touch a limit switch. That means I must go to my actuator and then click on my actuator, then also add onto the actuator my position or the sensing, position sensing. Now I'm going to use, that means go to the actuation labels. We're going to call it a label, make that, I'm going to call that A0. And that will be in my position number 0 and 0. That will be A1 for position number 100, for example. 100. Okay, that means now on my actuator, I've got my sensing devices. Now that sensing devices, what must be? I'm going to utilize, let me assume it is what we refer to a 3 to 2 way. Right, I'm not sorry, 3 to 2 way, sorry, re-switch. I'm going to go to the re-switch. That means the switches, guys. But this actually will be not in a DD. I will go to my electrical controls on this side, measuring, and here it will be my switches. Now I'm going to utilize what we refer to. Very important to understand this now. Okay, sorry guys, I'm in the wrong place now. I'm going to go back into that electrical measuring. That's it. Yeah, I want to use a magnetic. All right, here's a magnetic. That will be, for example, will be A1. All right, I'm going to connect this to my 0 volt line and that to my positive C line, and then I will also have actually what we refer to my relay. Solenoid valve. If I do this, I'm going to fit it into the window. Okay, and this will be not a relay, sorry, that must be my valve, solenoid valve. Okay, connect it here. And that must go to my 24 volt. All right, and this must be labeled as my A1. Okay, that means now this is what we refer to small wall control, indirect control. Right, I'm going to go to my simulation package. Is the moment when I press my start relay, this relay needs to be energized. I'm going to quickly now check what is the voltage on this relay. Right, I must change that into 24 volt. Okay, it means when I switch it on, right, press this, there it goes forward, and when it touches my front limit switch, I will actually then, all right, that's need now to be connected to Y3, all right, let me quickly connect that to Y3. That means I'm going to click on this one and make that Y3. And then I'm going to go to switch simulation package, press the start button, and then it goes forward and touch it, and it will go back. Right, there is a complete small automated system control with electro-pneumatics into your fluid sim. That is what we call indirect control. All right, guys, that's all for now. That's actually an overview of what you can expect when you actually come and do the proper electrical or electro-pneumatic course. If there's any questions, guys, I see there's a question, Charles.
Yeah, just no, I've asked. I haven't seen any questions. Just a call and like to catch up later. Okay, so some guys left.
Okay.
And let's see, where can I download this webinar? There's a question. What is the pressure switch? What is a pressure switch? Is a question.
Okay,
Sure
guys, to answer that question, what is a pressure switch, guys? A pressure switch, guys, remember now, it's actually an electrical contact. When you set the pressure switch, for example, let me assume 5 bar, your pressure are rising from 0 to 5 bar. The moment when it reaches 5 bar, then a contact closes, and that signal will be actually utilized into your control circuit. It is, for example, if you come to this one here, right here, this is actually a pressure switch. If you go to didactic and you say components, guys, I'll quickly show you this. This is what we refer to a pressure switch. All right, you can see it now. Right there it is. This is what we refer. I'm going to do it again. Sorry. This is a symbol for a pressure switch. When I click onto it and I go to didactic components, it actually will show you, all right, what that pressure switch is all about. This is a pressure switch. The switch relays on electrical signal when the pressure switch pressure at a pneumatic pressure switch is exceeded. That means the moment when you set this, for example, like 5 bar, and when you reach 5 bar, the electrical circuit, that means the contact will closes, and that 24 volt will be utilized as a criteria for on or off. It depends on your circuit itself. All right. Any other questions?
Yes, one guy asked if in the case of a filling machine that you demonstrated, how would you be able to stop the cylinder in any position in the center? Let's say 50%. That's one. That was one of the other questions.
That means your actuator, the position of the actuator. Right. Yes, you must know that then we will utilize a 5 to 3-way valve, right, with a mid position close. Let me quickly explain it to you like this. You can go to your actual direction control valves. Okay. Right. Hier moet ek nou my help myself help nou. Right. We see where is it? Okay, I'm going to go to this one, and then I'm going to modify. That means what we will use actually when we go to this, we can configure it now. Okay, this is actually where we have a mid position close. Okay, and then we have on this side we have right, it is, and your initial position will be on this side. Okay, no, sorry, in a mid position, sorry. If we make it in a mid position, it will be in a mid position. Okay, and then we use it as the come on, is it? Okay, guys, for that question that I asked, and what position, or if you want to leave your single or your double acting cylinder, actually your double acting cylinder into a mid position. What I'm going to do is I'm going to do this for you. Move that into position. Give me quickly a moment. Connect it. Okay, here is right. It means I can then actually also label it according to Y1 and also to Y2, Y3, for example. Okay, and there is a 5 to 3-way valve. All right, and that 5 to 3-way valve, it depends on. Let me quickly go to your simulation package. The moment when I press this, all right, I can actually, it will go to that position and it will go back. All right. But if you actually wanted to be in the mid position, guys, that means the mid position will determine where, in which position your actuator will stop. That means if I give it a signal currently, because I'm using it as a control now, I will change my control circuit in such a way that I will only give a pulse, for example, all right, and it must go to the mid position, for example, look there. And it will actually then supposed to stop in middle between, because I'm actually not controlling it correct now. But what you will utilize a 5 to 3-way valve to actually determine your position where you want to stop it. That's actually that. Charles, you can also, if you want to make your comments, you're welcome.
Okay, now there's another question that so how can I get the software for the circuit design?
Okay, I think everybody must listen to what Charles can tell us now within to your the smaller presentation. You guys need to reply back to Hannes. Hannes will send you the link where you can go download the software. All right, and they will supply you with a trial license for 3 months.
Yeah, and that is now if they do one of the courses.
Yeah, if they're attending one of the courses.
Practical training.
Yes, yeah. Attending one of the paid courses, that if you attending one of the paid courses, you actually will then be able to send a link. We will send a link to you, and then you can download it on your machine, and it will actually, you can utilize it for 3 months.
Okay, and then there was one last question. Somebody wants to know what is the reason for some 5 2-way valves to have double coils and while others have a single coil solenoid.
All right, it depends on, guys, it depends on the application again. Most of the times when it comes to safety, if there's a power failure and you don't want your system to stay in one position, then you will use a single solenoid spring return. That means the moment the power falls away, your machine will reset to home position. For safety purposes, you will use a a single solenoid valve spring return. That's the basic answer for that. Any other question?
Okay, Don. Yes, and then just the handout is actually under handouts on their screen. All the didactic training courses are, all the dates and the times are shown. So they can just download that and have a look at it.
Okay, that means, guys, go to your handouts. There is actually a PowerPoint presentation, or it looks like a PDF file that can show you all the courses that actually going to come up in the new feature. Please, guys, enroll into that, register online, and then do the courses. I'm going to quickly bring it also on into my screen. This is what it looks like the moment when you go there. This is actually Festo didactic training courses. Right, tomorrow we will do introduction to PLC, and then Friday we will do the next 4 days on next week, 15, 17, 19. We will do a basic pneumatics, basic hydraulics, electro-pneumatics, and then introduction to PLCs, and then also how to integrate Festo equipment with Siemens PLCs. This is the courses that are coming up in the new feature. But remember, tomorrow and Friday, we have an introduction to PLC course utilizing codices. And then Friday, we will actually explain to you in more detail how to utilize and what is the functionality and the power and the production, sorry, the capabilities of Fluid Sim when it comes to designing circuits and testing your circuits and analyzing your circuits on Friday. Please, guys, from 9 o'clock until 10:30.
Yes, and I think they should just also remember that they need to sit in on Friday if they are planning to do any of the other courses, the paid webinars.
Okay, yeah. Okay. Excellent. Right, I'm finished. So thank you, guys. If there's any questions, you're welcome to ask, but I'm finished with my presentation. And if there's any questions, you please ask. Do yourself a favor and download the handout, please. Download the handout here right onto your screen underneath the functionality called handout number 1. Please do that yourself a favor. Okay, thank you, Shaw.
Okay, thank you.
If there's any other question, please ask. Right.
Okay, so Davy, I think we will just be here for another 3-4 minutes. If there's no questions, we'll close the meeting.
Okay, thank you.
Okay, so anyone else with any questions, better ask now so that we can help you with your queries and make sure that you get all the answers you need.
Charles, I see Michael asked how to download the PDF. Michael, you only click onto it, into your handout. There's a handout column or a handout tab. Click onto it. It will open the PDF file. Double click onto it, and it will start downloading it automatically. Then there is somebody that asked a question. I see here's another question, Charles. What is the proximity? Guys, there's a question. What's the proximity sensor? All right. It looks like I cannot see now who's who asked that question. Guys, I want to show you what is a proximity sensor.
Yes, Lissagan.
All right, yeah. Let me quickly explain to you what a proximity sensor is. For example, I'm going to go to my PowerPoint and explain that to you. Okay, right on my screen now, you can see on the PowerPoint presentation, I've got a magnetic, all right. That means this small proximity right here is a magnetic. That means there is inductive proximity sense switches, there's capacitive sensors, optical proximity sensors, and coupling of pneumatic, electrical, and mechanical switches. That means this is a symbol. That symbol right within my main symbol there is that show me that we call it a proximity. A proximity is to sense the position of my actuator. As I extend my cylinder and it reaches the front or the fully extended position, I want to sense, I want to know what is the position, and that position will be in the form of a signal, a 24-volt signal. That means this magnetic, right? I'm going to bring it in for you like this. I will show it to you on my camera. Hold on for a moment. On for a moment. I quickly want to show it to you physically how that looks like. Right. You can see now on the camera. I think, Charles, you can also see it. Yeah. No?
It's changing. Yes, I can see it.
Okay, guys, you can see on the screen. All right. I've got my double acting cylinder here, and I've got my back position right here, and I've got my back position right there. That means this is 2 magnetic limit switches, a 3-wire. We call it 3-wire magnetic limit switches. All right. What is a proximity? All right. The proximity works like this. I'm going to show you on another actuator that you can see it right here on another actuator. Here's a square actuator. with a slot right here. That's my proximity sensor there, and this is also my proximity sensor right here. Right, remember it works on a magnetic field. Internally there's a magnet on top on my actuator, on my piston head. We call that a magnetic ring. There's a magnetic ring onto it. The moment when my cylinder extends, for example, when my cylinder extends, I will show that to you like this. If my cylinder extends, the front limit switch right here where my finger is will come on. When I return to the back limit switch will come on. That means this is two actually sensing devices that sense the position of my cylinder. And it works onto, I'm going to show it with you. I'm going to show it to you like this. Here is my symbol. It will be there now. Here's my symbol. This is my symbol. All right. I'm going to actually show you how it works. We talk about power on or power off. Right. This is it's actually what we refer to normally open, because normally open contact here. We got our 24 volt right on top here. We got our 0 volt right here, and then we got our signal. And that's the one that I've used in my circuit, in the electrical circuit. This is the one that I've used right here. The symbol right internally showed me that that is a magnetic proximity switch. Okay, that's what the proximity is, right? If I put the simulation package on, you see that your 24 volt, here's 24 volt. Here's my 0 volt on my actually circuit. Then this is my signal. It means, if I can explain it to you like this, the moment when you got your normally open contact like this, you got your 24 volt right here. Sorry for my right. That means the moment when you close, if I put actually a lamp right here, and I've got my actually this is my 0 and that's my positive side. The moment when I close my switch, my current will flow through and my lamp comes on. That's exactly what happens here. It means the moment when A1 senses that my cylinder right here is in position, right there in position, my proximity will sense that actually my actuator is extended, and my power will go through from 24 volt. It will go through to my signal here, and I will receive 24 volt right onto here. Right here will be 24. Oh, out of this. Right there will be 24 volt. Right there will be a 24 volt. That means, check what happens when I press my push button. All right, when I push my push button, the moment I reach A1, there the power goes through and it energizes my Y3, and that means it will send it back. And that's a proximity. That's what the proximity. That's the functionality of a proximity sensor. Now you get different proximities. This is a magnetic one. The principle is magnetic. There's optical signal. There's an inductive that works on a resistance. All right. Different ones, they're different ones. We discuss this in more detail when we do the electro-pneumatic course.
Right, okay, Darwin, and there was just one more question.
Yes, sir.
And just one last question. What are the costs for a 4-day webinar course? So basically it's $750 if you're outside of South Africa. If you're in South Africa, it's $750 plus tax.
Okay. Right, there you got your answer, guys.
Okay, and I believe that's all the questions that I could find here.
Okay, yes, there was a lot of guys that asked questions. All right. All right, thank you. Right, can we then close this meeting then, Charles?
Yes, I believe so. There's no other questions, so I think it's good. Thank you guys thank you everyone for joining us on this webinar. We will see you tomorrow for the introduction to PLC. Thank you. Bye-bye.